Lesson 13 workbook. We're going to scroll down here to question 10, and it says circle P has its center at P2, 1 and passes through the point 6, 1. Circle Q has its center at -2, 1 and passes through the point 0, 1. Okay, Regina is writing an informal proof to show that circle Q is similar to circle P after a similarity transformation followed by a rigid transformation. Which two transformations will map circle P onto circle Q? Okay, so a rigid transformation means it picks it up and moves the entire circle without changing its shape or size. So that would be a reflection, a rotation, anything that's going to keep it the same. A similarity transformation is going to be the scale factor. So there's your clue. We're going to have one of each. The other thing I'm going to look for, the other thing I'm going to compare is the coordinates for P and Q. P's coordinate has an x value of 2, and I'm comparing it to the x value at Q. They are opposites, so we have opposite x coordinates and we have the same y coordinates. So that is an indication to me of a reflection about the y-axis. And that's because a reflection about the y-axis, so if I just drew the y-axis and I picked any random dot or point, this distance, when I reflect it, it's going to stay at the same distance, which is our x coordinate, except for now it's going to be, instead of being, say, a +3 on the x-axis, it will be, this distance will still be a 3, but now it will be a -3 because it's on the left side. So this would be a -3 x coordinate and this would be a +3 coordinate. And so the indicator to me that it is a y-axis, to reflect it about the y-axis, is because the x coordinates are the same number with opposite signs. That means they're the same distance away from the y-axis. So point P is 2 units away and point Q is 2 units away. They're just on the opposite sides. And so and the other thing that allows me to do the y-axis transformation is because they have the same y-coordinate. So that means they lie along this same horizontal line. So that is why I would select reflect in the y-axis. And then that takes care of our rigid transformation. So now I'm looking for the similarity transformation, which is a dilation factor. And so how big is the radius P? So for circle P, and for circle P, the radius is equal to, let's count it. It says it passes through the point 6, 1. So right there. So from our center point, 1, 2, 3, 4, to the outside edge is 4 units, and that's our radius. So that's 4 units, and then Q's radius for circle Q, the radius is equal to, let's see, it says that has its center at -2, 1 and passes through the point 0, 1. So 0 up 1, and that's on the outer edge of its circle. So then let's count from its center, 1, 2. It's 2 units. Okay, so since I want to find the dilation scale factor, it's going to be radius 2 over radius 1, And since I want to make P on to circle Q, that means I want to shrink circle Q since it's the larger one. So it is going to be my radius 1. That's my first one. Radius 1, radius 2. So then we're going to have this as 2 since Q's representing our radius 2 and the radius for the circle's Q is 2 and the radius for P, since it's representing our radius 1, is 4. So we're going to have 2 divided by 4, which reduces down to 1/2. So then that's our similarity. So dilate with a scale factor of 1/2. So submit that for grading. Great job. Okay, so map, there we have it. So moving on to question 9, circle A has its center at A11 and passes through the point 5,1. Circle B has its center at -5,1 and passes through the point -2,1. To prove the circles are similar, Reina must perform a rigid transformation followed by a similarity transformation. Which transformation maps circle B onto circle A? Okay, so again, rigid transformation is a reflection or translation or rotation. So I would write that in my notes. Rigid transformations are translations, reflections, and rotations. Similarity transformations are going to be your scale factors. So there's a big clue right there as to what kind of answers you're going to give. If you select a translate, then you know the next one is going to have to be a scale factor. So let's see. Translate 6 units right, then dilate about its new center by a scale factor of 4/3. Reflect in the y-axis, then dilate about its new center by a scale factor of 4/3. Reflect in the x-axis, then dilate about its new center by a scale factor of 2, or translate 6 units right, then dilate about its new center by a scale factor of 3/4. Okay, well, let's talk about these translates 6 units right. So they want to take B to A. So if I take the center of B and I move it 6 units to the right, so 1, 2, 3, 4, 5, 6. All right, that works. That would land it at the center point of A. So far, that is what we would do for our rigid transformation, is to move it 6 units to the right. So then we need to check by a scale factor of 4/3. So what is the radius for circle B and the radius for circle A? So let's count those out. So from a point at its center to the point at its edge, so it's 5,1 for circle A. So from its center to 5,1 we have 1, 2, 3, 4. It's 4 units, and that's for circle A. And then for circle B, it has its center at -5,1 and passes through the point -2,1. Okay, so that's on the edge. So then my radius is from the center to the outside edge. 1, 2, 3. And so our radius is 3. And then they want us to map circle B to circle A. So this is going to be our R1. And this is going to be our R2. So our scale factor is equal to R2 divided by R1. And since the radius for circle B is R1, that's the one that we want to take, wherever R1 is, I'm going to write in a 3 by substitution. And then circle A is our second one, and its radius is 4. So our scale factor is going to be 4/3. So let's check. This one has 4/3. This one has 3/4. Our scale factor is 4/3. So that is what we want to do. All right. And one way I remember which one is radius 1 and which one is radius 2, it gives it to you in order. The transformations maps circle B, that's our radius 1, onto circle A, that's our radius 2. And so it gives it to you in order on how you can remember which radius is 1 and which radius is 2. All right, so points. Question 8, points E, F, G, and H lie on circle M. The radii ME, MF, MG, and MH are drawn in, as well as the chords EF and GH. Okay. Omar is told that angle EMF is congruent to angle GMH, and that the chord EF is equal to 2x minus 3, and the chord GH is equal to 10x minus 43. He is asked to find the length of GH. What steps should Omar take to solve this problem? What is the length of GH? Okay, well then let's just talk about what we know. We know that any two chords that have the same central angles are going to be congruent. So since we know that these two central angles are congruent, then we know that GH would be congruent to EF, which means they are the same length. So my plan would be to set EF equal to GH and then solve it. So that's what I'm looking for the reasoning. So then let's do that. So we have 2x. Okay. Since we have EF is equal to GH, because they are chords that have the same central angles, I can use substitution. EF was 2x minus 3, so 2x minus 3 is going to equal GH, which is 10x minus 43. And now we want to solve. And the goal for solving is to end up with a 1x. So we want to make anything that adds or subtracts, we want to make 0, and anything that multiplies or divides, we want to have be 1. So I'm going to collect all of my numbers on the left side and all of my x's on the right side. So first move my numbers. So addition, this is minus 43. My goal with addition or subtraction is to make it 0. So minus 43, I'm going to add 43. And I'm going to add 43 on this side. So we have 2x minus 3 plus 43 gives us a 40 equals 10x. And minus 43 plus 43 is 0, which is what we wanted. So then we have 2x plus 40 equals 10x plus 0 is just 10x. Okay, so since I still have an x on this left side, I want to move it on to the right side. So the 2x is positive since it doesn't have a negative sign. Since it's addition, our goal is to make it a 0. So we're going to minus 2x, use the inverse operation. So we're going to have 2x minus 2x, 0. That was our goal. Plus 40 equals 10x minus 2x is 8x. Alright, so 0 plus 40 is 40 equals 8x. All right, so anything with multiplication when we're our goal is to make a value of 1. So 8 times x, we're going to divide by 8 and divide by 8. 40 divided by 8 is 5 equals 8 divided by 8 is 1. That was our goal, and we still have x. So x is equal to 5. Alright, so then let's read our plans. Our plan was that since the central angles were congruent, we knew the chords were congruent, so we set them equal to each other and solved. Alright, so since congruent central angles have congruent chords, he should set the length of EF equal to GH. So 2x minus 3 equals 10x minus 43. The value of x is equal to 5. So GH equals 7. Okay, where did they get this GH length from? We only solved for x. Well, since we know the value of x and we knew that GH was equal to 10x minus 43, and we found that x equals 5, we used substitution, so we have 10 times 5 minus 43. So 10 times 5 is 50 minus 43. 50 minus 43 is 7. So yes, that is the correct solution. Alright, and we'll check it just to make sure. Great job. Alright, let's move on. Alright, question 7. Points R, S, T, and V lie on circle C. The radii CR, CS, CT, and CV are drawn in, as well as the chords RS and TV. Arc RS and arc TV have measures of 90 degrees. Okay. So if RS, this chord, is equal to 4x plus 8, and TV, that's the chord, is equal to 8x minus 23, what is the value of x? And then which statement justifies the answer for question A? Okay, well, we know that the arcs are the same. So since we know that the arcs are the same, we also know that the central angles would be the same. And since the central angles would be the same, we know that the chords would be the same or have the same value. So we know then that the chord RS is going to equal the chord TV. And we know that RS is equal to 4x plus 8. And that's equal to 8x. And TV is equal to 8x minus 23. So we're going to solve for x. So first we want to collect all of our x's on one side and all of our numbers on the other. And so our goal with addition or subtraction is to make 0. So we have minus 23, so I'm going to add 23. That's the inverse operation. And add 23 to 8. So we have 4x. 8 plus 23 is going to give us 31. Equals 8x, and negative 23 plus 23 is 0. That was our goal. So then we have 4x plus 31 is equal to 8x plus 0 is 8x. And then we're looking at this side. Now I have x values, and so I'm going to move my 4x to the other side. Since 4x doesn't have a negative sign in front of it, it is assumed to be positive. So with addition, our goal is to make a 0, so we're going to subtract 4x, and we're going to subtract 4x. So positive 4x minus 4x is 0. That was our goal. Plus 31 equals 8x minus 4x is 4x. So 0 plus 31 is 31 equals 4x. Alright, so now our since we have 4 times x, we want to make it a 1. So we're going to divide by 4 and divide by 4. Again, multiplication or division, you want to make 1. Addition or subtraction, you want to make 0. So 31 divided by 4 is going to be something less than 8. So let's find out exactly. And we're going to just type it in. 31 divided by 4. That's 7.75. Alright, so we have 7.75, and that's going to equal 4 divided by 4 is 1x. So our value of x is equal to 7.75. Alright, now it asks what is the value of x and which statement justifies question for the answer for question A. Select one answer choice for A and select one answer choice for B. Okay, so what's the value of A? A is 7.75 because x is equal to 7.75, and then we're going to look at it. B, because the arc RS is congruent to the arc TV, the chords RS and the chord TV must also be congruent. So 4x plus 8 equals 8x minus 23. That's exactly what we did. So I'm selecting that one. Alright, great job. Alright, question 6. Points W, V, X, and Y lie on the circle C. Radii CW, and CY, CV, and CX are drawn in, as well as the congruent chords WV and XY. Arc XY has a measure of 104 degrees. If the measure of VW is equal to 23x plus 4, what is the value of x? Okay, so what they're giving us is that we have this radius and radius, 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 and it also says that our chords are congruent. So since our chords are congruent, we know that their arcs are going to be congruent, which means they're going to be the same. So we know that arc VW is going to equal arc XY. And so since we know VW's arc is represented by 23x plus 4, that's going to equal the length of arc XY, which is 104. And then we're going to solve for x. So our ultimate goal is to end up with a 1x equals. That's our ultimate goal. So in order to meet that, we need to simplify everything. So we have a plus 4. I'm going to subtract 4 because that's the inverse operation. And so we have 23x plus 4 minus 4, positive 4 minus 4 is 0. And 104 minus 4 is 100. So then we have 23x plus 0, which is 23x, equals 100. Alright, we have multiplication. And so we're the inverse operation is division. So we have 23 divided by 23. So 23 divided by 23 is 1x equals, what is 100 divided by 23? So we have 100 divided by 23. That's going to give us 4.347. 4.347. Okay, so now let's check. That is what they want. They want the value of x, and we met our ultimate goal. Okay, so x is approximately 4.3. Yep. Which statement justifies the answer for question A? Is it because chord VW is congruent to chord XY? Their arcs must be congruent as well, so 23x plus 4 equals 104. Yes, that was exactly the reasoning why we used it, so we're going to check that. Submit it for grading and make sure. Great job. Alright, so there is your help for the workbook examples. If you would like extra help, please fill out a form or attend my live office hours.